Assalamu alaikum. Hello everyone. I am Saiful from the Computer Science and Engineering Department of Southeast University, and today I will be presenting on computer networking. In today's world, networking plays a vital role in communication, business, education, and almost every sector of our lives. Throughout this presentation, I will cover the fundamentals of networking, different models, media, topologies, hardware and softwares, and finally how an office network setup works in practice. Our first topic is computer networks. A computer network is simply a system of interconnected devices that can exchange data and share resources. This data can be documents, images, videos, and the hardware resources can be printers, scanners, storage devices. The software resources includes applications, databases, and all this can be shared on a network. There are different types of networks based on geographic area. These are personal area network, PAN, local area network, LAN, metropolitan area network, MAN, and wide area network, WAN. Firstly, personal area network, PAN, is formed among the devices of an individual's workspace. This network functions within a range of about 10 meters. The media used in a personal area network can be USB, infrared or IR, Bluetooth, and Wi-Fi. The speed on personal area network varies on the media used. Local area network, LAN, connects devices within a small area, such as home or office networks. The range of LAN can be up to 1 kilometers. The media used here are twisted pair cable, coaxial cable, and fiber optic cable. The speed ranges from 10 megabytes up to 10 gigabytes. Metropolitan area network, MAN, connects multiple LANs within a city or large area, like university campus or a cable TV network. The area covered can be up to 50 kilometers. The speed of metropolitan area network ranges from 34 megabytes up to 155 megabytes. Wide area network, WAN, connects networks over a large area such as countries or further. In a wide area network, fiber optic is mainly used to connect multiple local area networks and metropolitan area networks. The speed can be up to 24 megabits per second in a wide area network. The cost to transmit data is high due to leased satellite and telephone lines in a WAN. Networks can also be classified by ownership. These are public networks and private networks. Public networks are the networks that is open for anyone to use, offering wide accessibility but less security, while private networks are restricted to specific devices or users, providing higher speed and security. There are 5 elements of a network. These elements are the sender, receiver, data, protocol, and media. Sender is the one who sends data into a network. The one who receives data from a network is receiver. Data is the information being sent from the sender to the receiver. This data can be text, image, audio, and video. Protocols are the set of rules that define how data is exchanged over a network. Media refers to the pathways that data travels through in a network. Uses of network. The main use of a network is data transmission. Resources like hardware and software can be shared on a network. Data can be stored centrally on a server in a network. Hardware and software are used less because of network resource sharing, which lowers the cost. Data can be stored in a central server, creating a database. This ensures safety of data, and this data can be found easily. Looking into the future of networking, we see technologies like 5G, Internet of Things or IoT, and cloud computing transforming how we live and work. Our next topic is network models. To standardize communication, we use network models. The OSI model has 7 layers. These are physical layers, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. It's a conceptual model that helps us understand how data moves step by step. The TCP or IP model is more practical and used in real life. It has 4 layers: the network access layer, internet layer, transport layer, and application layer. The TCP/IP model is the foundation of Internet as we see today. Our next topic is network media. Network media are the pathways used to transmit data. There are two types of network media. These are wired media and wireless media. Wired media. In wired media, data transmits through wire connections. This method is faster and more secure. Wired media includes twisted pair cables, coaxial cables, and fiber optic cables. Twisted pair cables. In twisted pair cables, two insulated copper wires are twisted together. Data transfer speed ranges from 16 megabits per second up to 500 megabits per second. These type of cables are used within 100-meter range. Coaxial cable is an electrical cable with a central conductor surrounded by concentric layers of insulation, a metal shield, and an outer insulating jacket. There are two types of coaxial cable. These are thin net and thick net. Fiber optic cable is made of the strands of glass or plastic that transmit data as pulses of light. These cables are free of any side effects, resulting in reliable transmission without losing signal quality. Then we have wireless media. In wireless media, data transmits using electromagnetic waves. The wireless media are radio waves, microwaves, and infrared. Firstly, radio waves are a type of electromagnetic wave with the longest wavelength. They are mainly used for wireless connection because they can travel long distances. Microwave uses much higher frequency than radio wave, so performance and speed are higher in microwave. Infrared or IR is used for communication within a maximum distance of 30 meters. This infrared or IR are mostly used in remote control of TV and not suitable for computer networks. Our next topic is network topology. Topology refers to how devices are arranged in a computer network. There are 6 types of network topology. These are bus topology, star topology, ring topology, tree topology, mesh topology, and hybrid topology. Firstly, bus topology. In bus topology, devices are connected to a single backbone cable. there are terminators at both ends of this cable. The design of bus topology is simple and cheap. But if the backbone cable fails, the whole network collapses. Coming to star topology, in this topology, devices are connected to a central device which can be a switch, a hub, or a router. If a node is disabled, that doesn't impact the network. But if the central device fails, the network goes down. Ring topology. In ring topology, devices are connected in a loop and each node is connected to two other nodes. Data travels in a single direction. Ring topology uses token passing method. A node can only send data when it can catch the token. If a device or cable fails, the whole network goes down. Tree topology. Tree topology is also known as hierarchical topology. A router or server is used as root node in a tree topology. Tree topology network can be easily expanded, creating new branches. If the root or server fails, the network goes down. Mesh topology. In mesh topology, each node is directly connected to all the other nodes in the network. For n number of nodes, each node has n-1 connections and the total number of cable in mesh topology is n into n-1 divided by 2. This topology is very reliable. If a connection fails, the network still functions through alternate paths. But mesh topology is very expensive and not practical. Hybrid topology. Hybrid topology is the combination of two or more different topologies, and it is designed to take the best features of each topology. Hybrid topology is easy to expand by adding new topologies whenever one wants. If one part of the network fails, it doesn't affect the whole network. Our next topic is network hardware and software. To build a network, we need network hardware and software. NIC or Network Interface Card is a hardware component that allows a computer to connect to a network. It can be wired, wireless, or virtual network interface card. A MAC address is a unique hardware-based identifier assigned to each network interface card, and it is a 12-digit hexadecimal number. Next, we have network devices. Repeater. Repeater is a network device used to amplify a data signal and retransmit it so it can travel longer distances without loss. Hub. Hub is a device that connects multiple computers and creates a local area network LAN. When a data is sent through hub, all the nodes in that network receives the data. And we have switch. Switch connects devices in a LAN network, but sends the data only to the device it is intended for, unlike hub. Switch uses MAC address to recognize devices and send data. Router. Router connects multiple networks of the same protocol and transmit data. Gateway. Gateway connects two different networks with different protocols. It translates protocol to exchange data in different networks. Bridge. Bridge connects two or more network segments, turning them into a single network, and this network works like a single network. Optical Network Unit, or ONU. ONU is used in fiber optic networks and converts optical signals into electrical signals. They are usually provided by the internet service providers. Media converter. Media converter connects different network media, letting them transmit data. Then we have network softwares. IP calculator. IP calculator is a software which can calculate IP address, subnet mask, IP address range, network address, and broadcast address. Cisco Packet Tracer. Cisco Packet Tracer is a network simulation and helps to design and configure network virtually. Wireshark. Wireshark provides live view of network traffic. PRTG. PRTG helps monitor health and performance of networks, servers, cloud services, and applications. Our next topic is network protocols. Protocols are rules that determine how data is transmitted over a network. There are several protocols such as IP or Internet Protocol. IP or Internet Protocol addresses and routes data in a network. TCP protocol. TCP ensures reliable delivery of data in a network. HTTP or Hypertext Transfer Protocol is used for websites or web pages. FTP or File Transfer Protocol is used for file transfers. SMTP, Simple Mail Transfer Protocol, and POP, post office protocol is used for sending and receiving emails. IP address. IP address is a unique identity assigned to each device on a network. There are private and public IP and two versions of IP network, IPv4 and IPv6. IPv4 includes 32 bits and IPv6 includes 128 bits. Subnetting allows dividing networks into smaller subnetworks for efficiency, scalability, and security. Information that can be extracted from an IP address using a subnet mask are first and last IP address of a network, network address and broadcast address, network bit and host bit, the number of hosts, scaling the network size up or down. Our next topic is office network setup. To set up and implement an office network, all the information about the network setup and necessary equipment need to be gathered. Firstly, we have to determine the number of internet users in that network. Then we have to purchase network equipment such as router for internet connection, switch to form a LAN network, LAN cable, Cat6 cable which is a twisted pair cable, RJ45 LAN connector to connect the cable with devices, RJ45 LAN cable crimper which is a tool used to connect the connector with the Cat6 cable, RJ45 LAN cable tester which can test if the cabling is right or not, media converter if needed, and ONU device which will be provided by the internet service provider. Next, we have to get an internet connection from internet service provider. This network can be designed virtually using the software called Cisco Packet Tracer. Cisco Packet Tracer is a network simulation software made by Cisco Systems. It allows the user to design, configure and test a network virtually. The benefits of the Packet Tracer software are as follows: network modeling, hands-on learning based on real experience, reduction of cost, help prepare Cisco certification. DHCP configuration. DHCP is a protocol that automatically assigns IP address to devices and default gateway and other network parameters to the client devices. To summarize, today we looked at the basics of computer networks, network models and media, topologies, hardware and software, protocols and IP addresses, and finally office network setup. Computer networking is the backbone of modern communication, connecting people across the world. As we move towards the future, the importance of networking will only grow. And thank you very much for listening to me, and I would be very happy to take any questions.